Hello, this is Dr. Oz. In this video, I would like to show you how to calculate the naive forecasting numbers. But one thing I would like to point out is that this data is quarterly and for multi years, but that doesn't mean that you can only use these tools for this kind of setting. You could use these forecasting tools for daily data, weekly data, monthly data, and so on. So I just don't want you to feel like you can only use this data for the quarterly multi-year data. All right, so now what I'm gonna do is here, I would like to calculate my naive forecast. Okay, so these are gonna be my forecasted values. What I will do is, let me just color code this one so that you know that this is my forecast. I click on this column D. Maybe I shouldn't do that. Let me just highlight this area. That's better. And I will choose a different color here. So this is my forecast. Let's I choose a green color here. All right, so basically you cannot forecast for the first period, and you start from here and say second quarter of 1993 will be exactly the same as first quarter. So this is your forecast. So you may say, wait a second, this is the old data. Why am I forecasting the historical data? Because first of all, before we use the right forecasting tool, decide which one is the right forecasting tool, we need to validate our model. So that's what I'm trying to do. So I forecast the past as if I didn't know the future, and then see whether this forecasting tool does a good job. And then if it does, then I will use that forecasting tool for future forecasts. Right down corner, black cross, double click, so you can see my forecast for the until the end of 2019. All right, so let's say I'm interested in 2020 numbers, right? 2020 quarter one, quarter two, quarter three, quarter four. These are the values I'm interested in. I'm curious about them. So if I keep using the same forecast, basically I cannot go beyond 2021, because if I just keep going, basically I will not be able to calculate the forecast. That's okay. So, but this is my forecast area that I am interested in. If I think that the just if I think that this is the right forecasting tool. All right, so this is the area where I'm trying to forecast. Maybe I should color code this one even different. So this is what I'm interested in. Okay, maybe I will just do bold here. Okay, maybe even like red numbers or something like that. So now, based on this historical forecast, I need to know whether this is a good forecast or not. To be able to do that, I will calculate the error. So how do I calculate error? There are different ways to calculate error. Either you can do the reality, which is total revenue minus forecast, or forecast minus reality. So what I prefer to do is forecast minus reality. The reason is that this number will be negative in parentheses, as you see, whenever I underestimate the reality. So the reality was $2 billion. I forecast $1.7 billion, so I'm off by $0.2 million. And I underestimated, so that's why it's negative. I like this calculation better. So not reality minus forecast. I like to do forecast minus the reality. Okay, click on this cell, right down corner, double click. All right, so sometimes I underestimate, sometimes I overestimate. Under, over, under, over, under, over, under, over. It looks like there's a consistency. This actually makes me feel like there's seasonality. All right, so let's go to, so this is the problem, right? What's the problem? The problem is here that if I consider this over and under, and if I add them up and take the average, basically I will be always wrong. The reason is that negative errors will cancel out with positive errors. To handle that situation, we will take absolute value of those errors, or we need to take square values of those errors, because if you take absolute value or square value of those errors, the negative numbers will become positive numbers. Okay, so what I'm gonna do is here, I will say use ABS function in Excel, which will convert negative numbers to positive numbers. all right? So I don't need to see all decimals. Right down corner, double click, boom. So you see negative numbers became positive numbers, so I can add them up or average them. Or you could do square of these values, which square of the negative number is positive number. So then that will eliminate my also negative positive canceling each other problem, right? Double click. So these are your square values. So also to be able to compare different companies and different models, I strongly suggest you to use percent errors. Percent errors is very important. So what I'm gonna do is I will calculate here percent error and absolute value, ABS percent error. All right, so what does it mean? So I will just look at the error, divide by the reality. So that will give me how much I'm off, what percentage. So as you see here, I underestimate the reality here by negative 13%. Double click, we can see overestimate 28, underestimate 12% or so. You can see the performance of your model. However, again, if you don't want negative percentages and positive percentages cancel each other out, what you can do is ABS function of that. So you can see here that this is all the positive numbers. Okay, so that's fine. So we calculated all this. So let me just, since I have so much data here, click right here and view freeze pane, so that when I scroll down, I can see the headings. Okay. So now you can see that obviously you cannot calculate this. So I should eliminate for the future because I need to wait for this data to come for me. All right, so this is what's going on for our company. You have positive and negative numbers here, okay? So now what I would like to do is, I would like to calculate the sum of these errors and see the mean absolute deviation and the mean square error and mean absolute percent error. I need to calculate those measures to make sure that my company, my measure, my model is good. Okay, so what I would like to do is I would like to calculate those values. Right, I don't know whether I want to calculate the top or at the bottom, because if I calculate the bottom, I scroll down. I guess let's do that. It's okay. I don't want to destroy the structure here. So let me calculate the totals here. So let me just calculate total errors here. This is sum function of all the historical data. Okay. Maybe I will even use a different color here. Okay. So by the way, you cannot always calculate these either because these are future values. Okay. So now I took the total error, total absolute error, and total square error. And what I'm gonna do is I will make them numbers so it will be easier to see here. All right, and now what I would like to do also is that calculate my error measures. So one of which is mean, let me zoom in a little bit so you can see better. Mean absolute error. Or deviation, some people call deviation. Let's call it deviation. Mean absolute deviation, which MAD, or mean absolute error, MAE. And let's calculate another option, which is mean squared error. Mean squared error. which is MSE. And then also let's calculate the mean absolute absolute percent error. Let's call this one as MAPE, which I like it a lot because it calculates percentages, which is, I think, the best way to go. So what I'm gonna do is I will color code this area too. All right, so what I like to do is calculate the mean absolute deviation. Basically, you just take the average of your historical errors, and that gives you 260. So we are off by $260 million. Is it good, bad? It's hard to tell. So MSE, if you do the same thing, average, this is even harder to interpret because square terms, it's so hard to understand what does it mean even. We are off by 218,000. Actually, these are millions square, which is billions off. So it's just dollar square off. So it's kind of hard, but it's just, if you're comparing different models with one another, then these numbers became more meaningful. I like MAPE a lot. So what I'm gonna do is, this is gonna be the average of absolute percent errors. This is meaningful because this is normalized, and you can see that I'm off on average by 9%. So I'm on average off by, my forecast is off by 9%. So now what I would like to know is that, are these errors normal, or are they really off, right? So that's what I need to figure out. So to do that, we need to calculate the standard deviation. So standard deviation can be calculated two different ways in forecasting, that thanks to statisticians. Either we can multiply our absolute error by 1.25. Don't ask me why. Based on empirical data, study, research that they have done, scholars, they found that that's the relationship. This is my standard deviation. Or I can do basically the same approximation by taking square root of my square error. Okay. And which is around 466. As you see, there is quite a bit of difference between these two. So let me just use this data instead of this. I will just use this one based on mean square error. You could use either one, and these are approximations. So what I'm gonna do is, I'm gonna convert these errors into number of standard deviations. Errors in terms of number of standard deviations. So how am I gonna do that? I will look at my error here to see what's going on. So I will just look at my absolute error, divide by my standard deviation. All right, and that will give me how much I'm off from reality in terms of number of standard deviations. Okay, enter. So you can see that here I am off by 0.5, 0.6 standard deviation, which is acceptable. Anything less than 1 is pretty good. 1 to 2 is acceptable, I would say. More than 2 standard deviations, question marks. So what I would like to do is, I need to lock my red cell because I will use the same standard deviation over and over again. And I will click here and then double click. So you can see the standard deviations here, different values. Of course, I should not calculate this after 2019 December. So now let's see whether my forecast is doing good or not. So what I would like to do is I can color code these, by the way. What I can do is click Control Shift down arrow or highlight the data. And then under Home tab, you can see that you have conditional formatting. And you can see here that, let's say, we can put a new rule. And if okay, so if if the cell value is greater than 2 standard deviation, I would say that is not acceptable. And let's see whether I would choose fill color. Let's say red. Click OK. Click OK. So now you can see that my standard deviation here, three standard deviation error, 2 standard deviation, again more than 2 standard deviation here. So I had some situations where actually 1, 2, 3, 4 times that my standard deviations ended up being acceptable to me. But again, does it bother me so much? Not necessarily. Out of 115 quarters, my standard deviation is 4 times more than 2 standard deviation, which is I mean, again, if you think about it, 2 standard deviation gives you the probability of having more than 2 standard deviation errors 5%. So if I have 100 observations here and 115, I do expect actually have more than 5 red numbers here. So I have 4. Actually, it's better than really what I would expect. So this is pretty good. I don't see any problem here in terms of using naive approach. Okay, so I will use this template for my other forecast as well. Until next video, enjoy supply chain management.